All right, folks. So I want to talk to you about how to set up an Excel problem to find normal depth. So this is just to remind you a little bit about how to use Solver and how you would set this up with the Manning equation. So I want to start us with the problem statement here. We've got a flow rate of 15.7 CFS, a rectangular channel with a width of 5 feet, and you are going to find the normal depth under uniform conditions. The channel has a slope of 0.005 and Manning's N is 0.021. What I'm going to do is create cells that are labeled by my inputs and have units associated with them. So I've got Q, I've got W, it's 5 feet. I've got SO, my bed slope of 0.05, and I've got Manning's N of 0.021. Those are my inputs. The next thing I'm going to do is I'm going to create a cell for my normal depth. This is my normal, YN is essentially normal depth. And I'm going to put that in feet, and I'm just going to give it a number, say 1.4. Below that, there are other things I need in my Manning's equation. There are other things I need in my Manning's equation. So I'm just going to grab that Manning's equation and copy and paste it over into this right there. So KM, we are with feet, so 1.486 is what KM is equal to. And then I also need to find area, which will be in feet squared, and RH, which will be in feet squared, and RH, which will be in feet, which means I probably also need to find my wetted perimeter. So what I'm going to do, I don't know what normal depth is, right? But that's what I want to solve for. So I'm going to set this up so that I write everything as a function of that unknown normal depth. My normal depth times my width. My wetted perimeter would be depth times 2 plus my width. And hydraulic radius will be A divided by my wetted perimeter. I'm going to now calculate using all these cells the Manning's equation. I've got Km divided by N times area times RH raised to the 2/3 times SO raised to the 0.5. Sometimes if I get a little nervous, I will just cordon off things that are raised to a fraction. So I get a Manning's value of Manning Q of 32.58. Assuming my normal depth of 1.4 feet, but I'm solving for normal depth. I want this number 15.7 feet cubed per second. So I've got a couple options here. I could actually change this depth. Oops, I could change this depth. So if I change it to 1, oh, look, it goes down. And I could change this until I'm roughly in the realm of 15.7. Or I could use Solver. So I'm going to go to Data. I'm going to go to Solver. What I'm going to do is I'm going to set my objective. I'm going to set my objective to be my Manning Q. And I am going to say that objective should be equal to a value of Q that is given in this equation, 15.7. And then I have to say, by changing variable cells, I have to tell it what it needs to be changing so that Q equals 15.7. I'm going to select my normal depth right here. And then I'm going to click solve. And it will tell you Solver found a solution or Solver didn't find a solution. Here I got 0.85 as my normal depth, which is good to go. If Solver can't find a solution, you're going to want to double check your equations. Make sure everything looks okay and that you get a reasonable Manning value. You also want to make sure that you actually input a number for normal depth. It can't find a value if it doesn't know that this should be a number. If it doesn't have a starting point, you're essentially guessing a starting point for this. My last encouragement is this is a very simple example with a rectangular channel. When you get to more complex shapes, I would actually input all of the components of that here. Don't hard code it. Make it a function of individual cells. So instead of writing, right, area is 5 times 0.85, you actually want to make sure that you are using the cells. You actually want to write your area in terms of those different cells, because it's going to make your spreadsheets a lot more flexible and allow you to use them over and over again. All right, folks, calculate some normal depth. Good luck with Solver.